Hello. I think we can start the second part of our review. Thank you for joining me for the Wednesday's session and not the evening session during the day. That means I'm assuming that you're probably using your lunchtime to learn calculus. Good. Okay, that means what we have, we know how to integrate. I'm assuming that we have good practice and we are confident. Now we will just try to do a little bit of application. We will still integrate some of the relatively easy integrals, but some of them we will just leave like as an integral, okay? And I do have a few questions. Okay, that means this was the last integral. And now let's see application. That means the first question is section 4.5, not 4.5. 4.5 was the U substitution. 5.1, chapter 5. 5.1, the area between two curves. Okay, and for example, we will have this question. Find the area of the region enclosed by parabola x squared minus x and another parabola negative x squared plus 3x. Okay, that's when we definitely see that one parabola is open up, one is open down. That means they probably do like a loop. And we have to find the points of the intersection and then see how we can integrate. Let's, first of all, what we can do, let's maybe draw both of the parabolas and then we will find the points of the intersection and we will be a little bit easier for us. That means this is x squared minus x. I will factor out x because then I see the zeros. The zeros of the parabola is 0 and 1. Okay, okay, let's do the other one. This one I will factor negative x. And I can also see the zeros is 0 and 3. Because as soon as we know the zeros, the x-intercept, we know how to draw the parabola. 0 and 1. 0, you can see it's a common part. That means we will do this, x and y. And one parabola is 0 and 1, or a little bit too big because the other is 3. Okay, 0 and 1, up 0 and 3. 1 and 3 and 0. Okay. Okay, that we nicely see the region which is bounded by two parabolas. We can see which one is the top, which one is the bottom, because we just have to subtract the top curve minus the bottom one. But we will need that point. Okay, this is the point of intersection. Let's find. That means let's say curve 1 and curve 2. Points of intersection. Curve 1 must be the same like curve 2. X squared minus x, negative x squared plus 3x. Okay. Yeah, I think the x is 2, but let's see. Yeah, my parabola is a little bit because my question mark is not between 1 and 3, but I think it's 2. But let's see. Let's solve the quadratic equation. I will add x squared to both sides and I will subtract 3x. Then I will, let me remove this. Okay, I will write. Then I will factor out x, 2x, and I will have x minus 2. Okay, and this is giving me 0, this is giving me 2. That means 0 and 2 are the points of the intersection. This is 2. Okay. That means the area will be simply an integral, and we know we slicing the x-axis from 0 to 2. Okay, we can see the yellow slice, and the top curve minus the bottom. The top minus the bottom one.
Oh, it says.
Oh, I heard somebody. If you would like to say something, you can. I mean, I don't know if that was. If you if you are talking to us. Okay, sometimes we can share the microphone. Okay. Okay, hi. Okay, I know the computers sometimes, yeah, it's not, they are giving us hard time. Okay. Okay, that means who can tell me what is the top function? And I will just, oh, actually I have to make sure that I have room to calculate. The top curve is this one. And it's the parabola with the negative, yes, thank you, with the negative x squared, because it's the parabola up and down, and then we will subtract the bottom one, and the bottom one, of course, is x squared minus x. Okay, and I did say that we will set up the integral, but since the limits are so small numbers from 0 to 2, let's integrate. Okay, that means we will have limit from 0 to 2. This will be negative x squared plus 3x minus x squared plus x. Please remember to distribute the negative. That means we have 2 negative 2x squared plus 4x. Okay. Now, what is the integral of 2x squared? 2x cubed over 3. Thank you. And what about the integral of 4x? Just 2x squared, really nice. Okay, 0 and 2. And we can substitute 2. 2 cubed is 8 times 2, 16. And then 2 times 2 squared, 4, 8, I think. And 0 will give me 0 because it's just x, just algebraic function. Who can tell me the final answer? Negative 16 plus 24 over 3 is 8. It will be 8 over 3. This is the final answer. Okay, that means not bad. Okay, not bad with this one. Okay, let's look another area problem. This one, I am a little bit nicer to you because you don't have to integrate, you have to just set up the integral. Set up, but do not evaluate the integral that represents the area of the region bounded by two curves. X plus y squared equals to 12 and x minus y equals to 0. And we see that this is parabola like the other way, yeah, the function x with respect to y. And I hope that we will find the points of the intersection, but we can try to get the graph. And do you remember how to get the graph of negative y squared? Yeah? It's the same, it's the parabola. And since it's negative, it will be open in the negative, like in the direction of the negative numbers. Yeah, because now everything is with respect to x. And plus 12 means that we have to shift 12 units up or to the right. It's more appropriate. That means this parabola is something like that. Okay, and that's 12. Okay, and this is simply x equals to y or y equals to x, doesn't matter. I can say this way, but it's just the straight line. Yeah, that's nice. And we can nicely see, we can integrate in terms of y because we can, it's more pronounced, the right and the left. And that we can subtract the right curve minus the left one. And I can write the right curve is negative y squared plus 12, and the left one is just y. Everything in terms of y. Okay? So we will integrate the right minus left with respect to y. And the right is negative y squared plus 12 minus y. That's y. dy. Okay, But the only thing that is missing, the limits of integration. Okay? And the limits of integrations, because we're slicing the y. That means we will need that point, y sub 1, up to y sub 2. Right? We will need these two dots. Let's do it. The one curve must be the same like the other one. Negative y squared plus 12 equals to y. Okay, let's move all of the terms to one side, which I can add y squared. Y will stay and subtract 12. I believe that's the right signs. Yeah, if I will put, it is 3 and negative 4, Dave. Okay, we'll probably, because we can factor out 4 and 3 plus and minus, which means negative 4 and positive 3. Negative 4 and positive 3. Yeah, now I can add this. Okay, that's mean it is option A. We don't have to, because it's like maybe the other way. It's still a nice integral, but it's too, yeah, that's what we have to know. Okay, that means that's area. Now volume. Okay, that means you can expect 2 questions from the area. That's what I just solved. 2 questions from the volume, and then we will see. Okay, 2 questions from work, section 5.4, and 1 question the pressure. Okay, and you will ace it. Find the volume of the solid obtained by rotating about the x-axis, the region bounded by the curve, square root of x minus 1, and the x-axis between 2 and 5. Yes, only one question. I really try to, I pick the easiest applications, okay? Okay, that means first of all, let's see what we have. We do have square root shifted 1 unit to the right, yeah? 1, because the x-intercept is 1. And then that means this is 1, x-axis, and between 2 and 5. Okay, that means this is my region. And what I'm doing, I'm rotating this about the x-axis. That means I will have something like, let's do some, oh, I'm just trying to do the 3D. Okay, but if you can imagine, when we will slice, we will simply have like a disc, like a circle. Actually, I just need the circle with the radius, and this will be the radius. I can maybe write a disc, and that's the radius. That means in order to get the volume, we will integrate a disc. The area of the disc. Rotation with about the x, integration with respect to x. And this is just pi r squared. Okay, I can put pi outside. And now, how can I actually define that radius? That radius looks like the quantity y, but the radius is touching a function. That means it's defined based on that function. That means radius is y, and how function y is defined? We have the formula square root of x. Thank you. Thank you, Gabrielle. Thank you, Abdallah. Square root of x minus 1. That means this will be the radius. Just square root of x minus 1 and squared. That means we can just integrate x minus 1, but we're still missing limits of integration. Do you think you can tell me, you see the yellow slices, and do you see that will be the, which actually, I don't know. It's from 2 to 5. Yes, actually, I don't, hang on. I don't like, I will put this again, but even because this is our solid, right? I shouldn't go further than 5. That means this will be the solid, right? That's like just from 2 to 5. We can see from 2 to 5. Yeah. Okay, that means in this time, your instructor is asking you to evaluate this. Let's try. What's the integral of x minus 1? Integral of x? Yes, I'm looking at the n integral of 1, of course, is x. Okay, let's see if we can get the answer. First of all, we're substituting 5. 25 over 2 minus 5. And then we're substituting 2. 4 over 2, 2 minus 2. Oh, actually 0. 25 over 2 minus 25, and I lost my pi. It is 15, because this is 10 over 2, pi, of course. 10, 25 minus 10, 15 over 2 pi. Yes? That means we do have option D. Okay, also nice, yeah, nice question. Let's see another volume. Oh, I don't have the options. Okay, but we will see. But this one we have to set up. Do not evaluate the integral that represents the volume of the solid of revolution obtained by rotating a region bounded by x cubed and y equals to 4 and x equals to 0, about the x-axis. Oh, that's mean what we have. Let's draw this situation. We do have x cubed. Okay. Y equals to 4 will be that line. Oh, we need that point. I'm just trying to, let's say 8. Okay, let's say 8. It will be a little bit better with the calculation. And x equals to 0. What is x equals to 0? Is the y-axis? Is that the line? Okay, makes sense. That means this is the region, and we're rotating this. Yeah, I think x equals to 0 is the y-axis. Thank you for confirming. And we're rotating again about the x-axis. I mean, we will rotate, but now what kind of shape we will have for our cross-sectional area? It will be washer. Okay, I can try to draw this on the other side. Oh, a little bit too, maybe too long, because it will be like a reflection. Yeah, and this will be a little bit too long. I don't want to mess up. Okay. I mean, this is of course negative 8, and this will be like, yeah, that will be the shape. But I will, okay, I will not mess up. We know that this will be washer, and I can just write the one radius, the small one, the inner one, and the outer radius. Yeah, both of them are like defined for some x. But the x is between 0 and that point. That means let's maybe find first of all the point of intersection. Point of intersection, which means function x cubed must be equal to 8. Yeah, that's the reason that I pick 8. We will cube both sides. I mean, not cube root of both sides. This will give me x. And what is cube root of 8? Yeah, oh, okay, 2. That means that's 2. Okay, That means we can see we will slice this way. We will slice from 0 to 2. X-axis, because we will integrate in terms of x. From 0 to 2, and we just need that washer, the area of the washer. Do you remember the area of the washer? Who can write for me? It's like a 2 circles. Yeah, we have to take the like 2 discs. One, the big disc minus the small one. Pi r squared minus pi r squared. From 0 to 2, I can put pi outside, and I need r squared minus r squared. And that's, we need the outer and inner. And now who can tell me? I can use blue color. What will be the, actually, what is the outer radius? The outer radius, we can see, is just simply, it's just simply 8. Yeah, that's 8. And what about, because that's the y value, and what about the inner radius? It's the y value, but in terms of x, how this y is defined? Okay, I think I have it, x cubed. Okay, that means this is 8 and this is x cubed. But Dave, can you see? I don't know if we have to square it because it's r squared. That means the final answer. Please remember, don't, because if I will create the options, I will, of course, I will put some options that are not correct. That means please remember 64 and x to the power of 6. We multiply this. This is the final answer. And we don't have to integrate. Okay? But please remember the disk method and the washer method. For the area, we need to know like the curve with respect, I mean the y function with respect to x, and the x function with respect to y. That's what I just solved. Okay, that means that's 2 questions for volume. That's what you can expect. And then, okay, now section 5.4. We did have work, okay, work. And I picked just two problems, like question like that, and the spring one, okay? That's, let's solve both of them. Okay, a cable that weighs 4 pounds per feet is used to lift 900 pounds of coal up a mine shaft 300 feet deep. Find the work done. That's, we have to take everything up from the 300 feet deep, and what work was done. Okay, we can kind of, I don't know if I can, maybe I can just draw it like that. This will be the cable, and let's say this is that's the bucket with the, and this is like 900 actually. You probably know the answer almost right away. 900 pounds. But also the cable, right? The cable has its weight. And like, we remember what to do. We will divide for the small parts, because when we lifting the cable, we of course applying some work is done, but as the cable is getting shorter and shorter, we need less work. That means it's not constant. The only constant will be this, which actually you can tell me the formula. Okay, the formula for the, like, we will ignore for now, because we will compute the work, but we will ignore for now the weight of the cable, just how much work is done to actually take up this 900 pounds of coal. Yeah, of course, it's the weight times the distance. That's it. That means we can say that the work is just the force, which in this case, the force is weight, because we know if it's not metrics, we are not worried for the acceleration due to the gravity and so on. No, just that means this is that force times the distance. and distance is this, which will be 900 times 300, and this is pound feet. 9 times 3 is 27, and 4 zeros. Pound. Okay. That means that's done. Yeah, that's this is like physics algebra base. Yeah, that's if you took probably physics algebra base, or we still have a second part of this question, physics calculus based. Because now let's find the work that we need to do to lift that cable, because that's also, yeah, that's also, and then we will add them together. Okay, that we can focus on one, yes, like one small part. And we of course know that this is delta X, and we have 4 pounds per unit, per feet. That means we will say that this is the work that is done is simply, the work that is done is like 4, because we have to get that force, 4 times delta X, but how can I write 4 per that distance? Okay, it's like 4 pounds per that distance. That means now if we have 4 delta X, and also we have to apply the distance that we will, that means we will always look at the distance above. Okay, that means this is X sub I. Okay, that means it's the weight times the distance that I have to lift it. And of course, my distance X sub I will change from 0, and how deep is, how, it's 300 feet. Yes, I was going to 300 feet and 0 feet. And as we can see, we have to 4, I mean, the weight will be 4 times delta X. That's the 4 pounds per unit per feet, and then times the distance that we're pulling, which is X sub I. Okay, but this is just one of this part of the cable. Now we have to add all of them from 1 to n. And we know that they have to be teeny tiny, which means that we have to have a limit, which means limit is indicating that the number is infinity. And let me put it this way. Okay, and we recognize the Riemann sum. Of course, this is work. Limit of the sum is just the integration of 4 times the distance, yeah, the 4x, and dx. But dx is, we integrating with respect to x, and it's changing from 0 to 300. Okay, and I think I will ask you to evaluate this. That means, what's the integral of 4x? Can you tell me what's the integral of 4x? Because it's not difficult. Yes, 2x squared from 0 to 300. Hopefully we can evaluate this. This will be 2 times 300 squared. Am I right? Because 0 will give me 0. 300 squared is 3 times 3 is 9, and 4 zeros, because we will double the zeros. Okay, 2 times 90, 180, and 3 zeros, 1000. Okay, that means this is that's the work of the coil, that's the work of the cable. We have to add together. Okay, that means the total, it will be 2 and 1. What's the final answer? 180,000 plus 270. Okay, I'm trying to give you 180 plus 270, 450,000, and it's just pounds feet, because it's not SI. not like newtons. And okay, I'm trying to divide. Okay, that means that. And please, okay, please make sure that you solving some problems on your practice test, you will see this question also similar. Okay, that you make sure that you know this type of question. And we know it's 4, because it's just 4x typically, 4 per x and delta x, because we slicing each part. Okay. The next question that I choose is, okay, it's multiple choice and it's the spring. Yeah, we remember this. A force of 5 pounds is required to hold a spring stretched 2 inches beyond its natural length. How much work is done in stretching it from its natural length to 8 inches? Okay, or from its natural length to 8 inches beyond its natural length. Okay, so we can imagine, let's say, a wall, a ground, a spring, and some weight. Actually, this weight should be maybe touching the ground, right? It shouldn't be. Shall I do the spring in the middle? Okay, that means we remember that's 0, that's natural. Okay, and then we will move 2, okay, inches, and then we will move 8 to 8 inches. First of all, you may see the multiple choice option. Do you see inch? Do you see inches? That's mean what we have to do, because we have to convert the units. Yeah, please do not. Probably using 2 and 8, you will realize that something is wrong. That's mean, let's maybe check. Like, can you tell me 2 inches? What is the part of the foot, of 1 foot? 2 inches. Okay, well, yes, I think I like, because let's avoid since we think it will be 2 out of 12. Of course, that means it is 1/6. And the same let's do with 8. 8, because using decimals, it will be complicated. We don't have a calculators. Okay, 8/12 dividing by 4, 2/3. That we will use this. Okay, that means this is theoretically 1/6, 2/3. Okay, and we remember what was the name? Like the Hooke's law. Hooke's law, that the force is defined as a kx. Yeah, some coefficient times the distance. And we know that we need 5, the force of, because it's the weight of 5 pounds moving 2 inches, which I will put 1/6 foot. Okay, and we can compute k. Can you tell me what is k equals to? K is 30. Perfect. Times 6. 5 times 6, not 60, 30. That's when we do have our function. Okay, we do have our function 30, which means my function is just my force, it's 30x. And that's the 30. And in order to find the work, it's not a constant, because the distance is making work harder. We will integrate f of x. I will put f of x. We will integrate, because as soon as it's not constant, we have to integrate. Integrating means checking the force, the work at every single sub-interval and adding together. And we know that this is the formula, 30x. Now, who can tell me the limits of integration? Because we're looking for the work done on what interval? Yes, from 0 to 8 inches, but please do not put 8. 2/3. 2/3. Thank you. That's me done. Yeah, don't put 8. Okay. What's the and again, your instructor is asking you to evaluate this. What is the integral of 30x? Perfect. 15x squared. Computing from, oh, that's 3. We can ignore 0, of course. That means we only have 2/3 squared. 15 times 4 divided by 9. Or we can simplify 15 and 9, which will be dividing by 3. Yeah, we don't have to produce huge numbers. 20 over 3, and of course it's foot-pounds. Oh, did I write in the other one pounds, foot-pounds, foot-pounds. Okay, so this is the answer. But what I want you to know, okay, the function, of course, this, okay, and then we have to know that we have to just integrate that f of x, kx, and find the k based on the given information, yeah? The distance and the weight. Okay, and I do have, and I believe this is the last question that I have. Okay, you probably recognize this. I just want to give you, yeah, the easiest, yes, the easiest shape to calculate the hydrostatic force. Okay, that's when you remember from the self-assessment. I think I gave you the trapezoid. I gave you the down, but the concept quiz, I gave you the aquarium. Okay, that's mean what we have. We do have, let me move it. We do have the aquarium. You can try to solve it, and I will, of course, I will solve it. Yes, I will. Okay, 7 meters long, 6 meters wide, and 4 meters deep. And it's full of water. Calculate the hydrostatic force on one end of the aquarium. And the end is one of the wall that is 6 by 4. I'm making sure. And since we have SI units, the metrics, we have to know the density of the water, and I will give it to you. It's a 1,000 kilograms per cubic meters, and the acceleration due to the gravity, of course, 9.8 meters per second square. Okay, let's see what we need. Maybe you know the answer. Because I can write but no, I will draw the aquarium for you. Oh, it's 6 wide. That means it's almost like a square. Okay, and then 4 deep. I mean, I can tell you, I will give you almost identical question. I will just change the numbers. Okay, and we're looking for the pressure, which works on one's side. Okay, that's 7, that's 6, that's 4. And the same thing, we will try to find the pressure on one, like, yes, because we like slicing, because at every single height, we have different pressure. It's more water, right? When you will think like at the top of the aquarium, it's not much, yeah, because we don't have that weight of the water. But at the bottom, the pressure is of course, stronger. Okay, that's, we do have this one slice, okay? And the slice, of course, is delta x. That means what we need the area of this, right? First of all, we need the area of that slice. And the area of the slice, it's simply length times width. Can you tell me what will be the area of this? You can tell me, because I'm just 6 times delta x, of course. I'm trying to 6 times delta x. Excellent. The second step, we will need pressure. Okay, and pressure, we know that pressure is the force, like the force over the area. Shall I write all of the formulas? I can write actually for you, but what is helpful to know, that the final answer will be the rho, the density, acceleration due to the gravity, and the depth, which is always like the height above, which we will call x sub I, because we always have that x. If this is, right, if this is like, maybe I can write, that's the x-axis, and always the level of the water is 0, and this will be 4. I can write this. Okay, that's me. And this is like x, that's the x-axis, a little bit upside down, which means from 0 to x and up to 4. Okay, that means that's the depth, which actually I can say x sub I. Yeah, that means you may remember this, yeah, right away. Density times the acceleration due to the gravity and the depth. But overall, general formula for the pressure is force, yeah, acts on that area. Force is mass times the acceleration due to the gravity. Okay, and then mass, yes, mass, like what is the mass? Mass is like the weight, which we will need the density and the volume, because mass is like we need the amount, which is the volume of that water, and the density. That means mass is simply rho times the volume and still g. Okay, I'm trying to derive the formula for you. That means rho will stay, and actually volume, okay, volume is always, we remember the like what we're looking at, like we kind of looking this direction, like a volume of that slice of water. That means we will need the area of this green slice times the depth. That means we will have the area, okay, times depth and times g. And now we can see the area actually, yes, the area is gone. And then we will have rho, g, and depth is actually x sub I. Yeah, that's what we applying. Okay, that means you may remember right away, because you don't have to like go through all of the formulas. The pressure will be rho times g and times x sub I. Yeah, times the, I can actually put the depth, like how deep we are. Okay, and I can compute this, 1000 times 9.8, and I will keep this for now, x sub I. Okay, that means this is pressure. That's the pressure. Now we need force. Okay, we need force, and this is everything for one slice. Okay, that means force is simply pressure times the area. Okay, pressure is 1000 times 9.8 x sub I, and the area is simply 6 delta x. And we know that this is just one slice. In order to add all of the slices to cover the distance from 0 to 4, I have to integrate. I can still write for you, I didn't use my slide. Do you know the answer? You can tell me the answer. Hang on, I'm trying to for you to have the nice notes. I need eraser, and I need to. Okay, Dave has 24. Okay, let's see. Maybe, I don't know. Let's see. That means this is okay. That's the. I can maybe use the next slide. You will have it. Let me write one more time. Okay, that means force of one acting on one slice will be pressure times the area, which is 1000, 9.8 x sub I, and the area was 6 delta x. Okay, but now we need the for all slices, which will be the summation from one slice to n, and we have infinitely many of them because then it's a perfect, and the same formula. 9.8 x sub I 6 delta x. And now finally, you may skip all of this. I can show you. You may say right away, integration of 1000, 9.8 x, because we slicing the x, and with respect, of course, to x, delta x. Oh, I'm missing 6. What we slicing? What interval? What is the depth of the aquarium? That's what I have to check every single from 0 to 4. Okay, I mean this is 1000 times 9.8 will be 9,800. Integral from 0 to 4, 6x dx. I can make better look. Oh, that's 8 actually. Okay, what's the integral of 6x? Yeah, we will, okay, good. 3x squared. And we have to evaluate from 0 to 4. That means again, I'm assuming it's not bad calculation. 0 will give me 0, but 4 squared. 9, 8. Okay, what's 3 times 16? Yeah, no, it's okay. As I said, we do have, it's 48, and we do have, can you see, that means we all know 9,800, but now it's, yeah, make sure that you pick up, that you set up a good integral, and yeah, and pick the correct answer. This will be the correct one, 48, and we have newtons. And I believe we can do it without the calculator. That means let's look at the shortcut. If you will see this question, of course you have to identify the area, because we will need the area. But you know the area. Length 6 and the height delta x. And then actually, you know that we will integrate the height from 0 to 4, rho g x, and then that area. Yeah. I'm just really trying to give you a shortcut. That means you will have rho and g, which will give you 9,800. X is always, yeah, because we always have that depth x, and you have to put, oh, I'm a little bit wrong, because, oh, no, I have to be careful giving you, because can you see delta x, it's dx. Okay, I will put 6, which means this is that area together. I can't put a, I will like kind of double the delta x dx. Okay, that means the hydrostatic force will be just, again, density times the acceleration due to the gravity, x, the depth, and 6 times delta x, but this is dx. Okay, if you, then that means theoretically it's just, yeah, just this blue, but you have the nice step-by-step explanation. Of course, a beautiful Riemann sum integral, and that's the answer. That means I will give you similar question, I will just change the numbers. Okay, 7, 6 meters, 4 meters, I can like play around. That means make sure that you know what numbers you integrating and what numbers you substituting instead of x. Okay, and as I said, that's, yeah, that's everything. Yeah? Even if it took me long time to solve this question, you can really speed up. Yeah, I know that. Okay, that means that's everything. Make sure that you do your practice test for extra credit and for good preparation for the actual test. And the same message, I know that I'm repeating myself, do not miss any question from this session. Okay, You may still type, you may still post something on the discussion board. Is optional. Yeah? You will get extra credit for posting something. Yeah? If you take the test and you have some question, you may email me. Do not put the exam question on the discussion board, okay? Because that's not really good. But you may email me and I will help you. But except the exam question, you can post any question on the discussion, and I will also monitor the discussion. I will answer. If you will ask a math question, I will definitely answer. Okay, okay, that's everything. Okay, that's been good luck with your review. Do the samples, do the practice, do the practice, and go through again my questions. And I know what you will get. If you will do all of these 3 things, you will be more than good. Okay, I will still watch you, and you will hear from me, of course, next week. But please, we will be of course in touch. Thank you, and good luck with your midterm 1. Thank you.